So finishing up this chapter, yay! The last thing we're going to talk about is molecular formula. The molecular formula being the true formula of the compound. And there are two things that you always needed to find the molecular formula. The molar mass of the compound and the empirical formula. Okay, the molar mass of the compound is always given to you. You can't solve the problem without it. Okay? Don't ask me what happens if it's not given, because it is. And in class, somebody always says, but what happens when it's not given? It will be. Okay, and you need the empirical formula. The deal with the empirical formula is you may have to find it, and maybe it's given to you. Yeah. So there's two kinds of problems here. We can have one that's shorter and easier, where both of these guys are given, both the molar mass and the empirical formula, and longer, where you have to find the empirical formula and the molar mass, again, is given. Okay, this is not like when we started this chapter, speaking about empirical formulas, where I gave you a molecular formula and said, oh, what's the empirical formula? And you saw if you could divide it. That's easier. This one is definitely harder. So let's start with an easy one. For some reason, I inadvertently went back to carbon and hydrogen, and I apologize for that. It wasn't what I planned on doing, but it's what I wrote down anyway. So you are going to find the molecular, that says MOLC, molecular formula for a compound with a molar mass of 78 grams per mole and an empirical formula of C1H1. Okay, so 78 grams per mole. That's the molar mass of the compound, and the empirical formula is C1H1, so that makes it fairly easy. When you are at this point in your problems, even if you have to solve for your own molecular formula, you're going to always do these three steps. First, you're going to find the mass of the empirical formula. You've got one carbon and one hydrogen, so 12 plus 1, again, I'm doing this as simply as I can, is 13 grams. Then I wrote this backwards the first time. Then you divide the mass of the true formula, or the molar mass of the compound, which is 78 grams per mole, by the mass of the empirical formula, 78 divided by 13. Okay, that should give you a whole number, and in this case it does. It gives you 6. What this is telling you is that there are 6 of these C1H1 units in the molecular formula. So again, you're going to multiply the empirical formula by the answer to step 2. So let's take C1H1, multiply those subscripts by 2, and you get C by 6, and you get C6H6. Okay, that is an easy one. That's the kind everybody always wants to get. That isn't what you're always going to get. So that's why it helps to know how to calculate the empirical formula. Does that chart look familiar? Okay, so again, we have another hydrocarbon. A hydrocarbon is, okay, this is example 2. And a hydrocarbon is simply a compound made of hydrogen and carbon, hence the name hydrocarbon. So don't let it bother you. And the hydrocarbon has a molar mass of 42 grams per mole. I told you that would be given, and it is. And you have a percent composition here. It's 14.3% hydrogen and 85.7% carbon. And I need to find the molecular formula. So what's the first thing you need to do? You have to find the empirical formula. So we're going to fill out the little chart again. So we can just take these percentages and convert to grams. 14.3% is going to give me 14.3 grams. 85.7% is going to give me 85.7 grams. Sometimes students get confused if they are given grams and not percentages, and they don't know what to do. If you've got grams, just fill it in. But that always seems to be something of a problem. Now, to go from grams to moles, remember I divide by the molar mass. So that would be, I'm going to try to squeeze these in somewhere over here. 14.3 divided by 1 is 14.3. 85.7 divided by 12 is 7.14. Not that you can read that, but I'm going to put it down here. So 14.3, 7.14. Now to go from moles to mole ratio, each of these gets divided by the smallest one. So we have 7.14 divided by itself and 14.3 divided by 7.14. Okay, dividing each number of moles by the smallest number of moles. That gives me 2 moles of hydrogen and 1 of carbon, or a ratio of 2 moles of hydrogen to 1 mole of carbon. Well, that's pretty, well, we can actually do it to 2 sig figs, yeah. That's pretty easy to make a formula ratio about from. I need to make these integers. And 2.0 is 2 and 1.0 is 1. So my empirical formula is C2H1. Sorry, I didn't just do that, but I did. CH2. Students have asked if you can put H2C, but generally when you're writing anything that is a hydrocarbon, you're going to put C, then H, then possibly O if you have it, then N. Okay, so you'd list them in that order, but it would be C, then H, then O, which is why I put the C first. No, I won't mark it wrong if you put H2 and C, but you should know that C goes first. Okay, so our empirical formula is CH2. Now I need to find the mass of the empirical formula. C plus H is 12 plus 1 plus 1 equals 14 grams. Now I'm going to divide the masses. I'm going to take the mass that was given up here, the molar mass of the compound, 42 grams, and I'm going to divide it by 14 grams, or 14.0 grams. That gives me 3. That is telling me there are 3 of these CH2 units in one of these compounds. So I'm going to take my empirical formula, CH2, I'm going to multiply it by 3. Remember, I'm multiplying the subscripts. That gives me C3H6. So my molecular formula is 3CH6. And that is a harder one. So the only difference between that and the first one is you have to do this chart first, then you do the 3 steps for finding a molecular formula from an empirical formula. You guys are going to have lots of practice with this, so don't panic. Just go back to your notes.